Ma'am, can you able to hear me, ma'am?
Yeah, Rajeshri, can you able to hear me?
Yes, ma'am.
Okay, let us start, ma'am.
Okay, ma'am. So, good evening to all for the third day of AICT sponsored 2 weeks Atal Faculty Development Program. Now, I request the program coordinator, Dr. F. Riya, Professor and Head, Department of Electrical Electronics Engineering, to welcome the gathering.
Good evening to one and all present here. I am very glad to invite you all for this third day AICT sponsored 2 week Atal FDP. Actually, when we start this FDP, we first and foremost job is to fixing up the chief guest or the session speakers. So we have tried all over India. I think you people know that the day before yesterday, Dr. Ramakrishna Chala from NITTR Chandigarh has delivered your session. And yesterday, Dr. Diana Moses from Hyderabad St. Peter's Engineering College, she has delivered the session. And today, the eminent professor Dr. Parameshwaran from Erode Kongu Engineering College is going to deliver this session. Similarly, day after tomorrow, you know that Professor Gonsai from Gujarat, one of the NAAC expert member, he is going to delivering the session about NAAC accreditation, and then Dr. Vijay Kumar, principal of Vivekananda College for Women. He is also going to delivering the speech. Then we have Dr. Renuka Devi from NITTR Chennai. So many eminent professors are going to deliver this Atal FDP session day by day. Today on this line, today Dr. Parameshwaran sir. Good evening, Parameshwaran sir.
Good evening, ma'am.
Good evening, sir. Thank you for joining this Atal FDP.
Thank you,
Actually,
ma'am.
when we contacted Parameshwaran sir, immediately he accepted our invitation. Even I know that we are we people every day we are busy now. Like corporate people, we are also having target. We have also so many job. Then you know that sir designation, sir is doing coordinator job also. He is taking care of placement also. So how much busy in contacting the industry people? How it is tough to contact industry people and ask the industry people to join with the institutions. So that kind of responsibilities are handling in his college. So even though his busy schedule, when we contacted Dr. Parameshwaran sir, immediately he accepted our invitation and ready to deliver the session on today without hesitating. So I would like to thank on behalf of Ahmed deemed to be University and Department of EEE, along with our faculty member, I welcome you all for this third day Atal FDP session, sir. Actually, we are very grateful to you, sir, for accepting our invitation. Madam Rajeshri, madam, kindly introduce the sir to the gathering.
Sure, ma'am. Thank you, ma'am. Thank you for your warm welcome. I extend my cordial welcome to the chief guest, Dr. R. Parameshwaran, Professor, Department of Mechatronics Engineering, and Chief Coordinator for TBI, Placement Training and IEF Forum, Kongu Engineering College, Erode. He has more than 25 years of experience in teaching and research, and also published more than 75 articles in referred international and national journals. His specialization on the area of fuzzy multi-criteria decision making, production and operations management, and quality engineering, etc. He has to his credit of more than 5 projects funded by AICTE, Government of India, and other agencies, and also organized more funded programs. He is the president of Institutions Innovation Council and also a member in ISTE, Indian Institution of Industrial Engineering, and associate member in Institute of Engineers. Good evening, sir. I invite you to deliver the session address.
Thank you, Rajshri ma'am. Thank you, Priya ma'am. And thanks for the organizers for giving me an opportunity to discuss with the people those are working in the area of outcome-based education. And hope my voice is audible. Can you hear
Yes,
me?
sir, you are audible only, but
Yes, sir. Yes,
a
sir.
little bit low. But what about others? I don't know. Can all of you can be able to share, sir?
Yeah, ma'am.
Whether it is
Yes,
audible?
Yes, sir.
yes,
Yes, sir.
yes, sir, you're audible.
Yeah. Thank you. Uh, First of all, I thank the organizers, Priya ma'am and Raji ma'am, and the other organizers who are part of this session. And as ma'am pointed out, I'm happy to have to join this elite group of speakers. Happy note on it. And let me come back to my topic. As the previous speakers have introduced something about outcome-based education. Once, if you have decided that we are going for OBE, then the next part will be the curriculum design. So the topic for me is all about, for the next 1.5 or 2 hours, I'm going to talk about how to build your curriculum and why it is necessary to have a holistic and multidisciplinary approach when you are designing a curriculum in OBE based education system. So that is the topic given to me, and hope I'll take you to the how we do at Kongu Engineering College. I was heading Kongu Engineering College Mechatronics department for 10 years, and now I have been shifted to TBA for the past 3 years as a head of technology business incubator, where we nurture and we support the young startups. And second thing, I'm also taking care of the placement and training activity of the college. So when I look into these two aspects, one is as a role, what I played as a head of the department. So technical expertise, how much is required when you design a curriculum related to your department? That thing I can understand it. Second thing, when you look into the outcomes of any graduation or any engineering curriculum, the outcome will be either students will be looking for campus placement, that is career path. If you look into their career path, they will be looking for campus placement, or second thing, they'll be looking for higher studies, and third category, they'll be looking for some entrepreneurial ventures. Since I've traveled along all these three aspects, and I think I can justify the selection of my role for this topic, since we are supporting or nurturing at startups. So this is going to be the next era for the engineering education. So far people thought of campus placements as one of the measures. Second thing, people those who are going for abroad or clearing competitive exams, gate examinations, and moving up, this is taken as a success of your curriculum. And third aspect, now it is essential, it is the right time for us to groom our graduates, those are moving out of our colleges, to become startups. Because you know that people are talking about gig economy. So once in the gig economy, we look for people, or down the line, when you look another 10 years or 15 years down the line, this group of people who are working as a freelancers for various companies, this will be a modality of their employment. If that is going to happen, how do we design our curriculum? So these are the things I'm going to discuss for the next 1.5 hours. Let me move on to my presentation, and please share me whether it is visible or not. Hope it is visible.
Yes, sir.
Yes, sir, visible, sir.
Yes, ma'am. So the topic is I'm going to deliver is restructuring the curriculum towards holistic as well as multidisciplinary education. So why these words? Already we do have a good curriculum in our packages, in our colleges or in our universities. Our curriculum is, at least we collect the feedback from the employees, what is required, we are able to inculcate into our curriculum. So this is what happening. Now, why does why it is need for holistic development, and why there is a need for multidisciplinary approach. Because down the line, if you look into the next few years, the technologies given by NASCAM or any other world skills, all these platforms are looking for people who are having a sound knowledge, who are having a good skills, and third category is people with great attitude and behavior. So this is how, if you look into the program outcomes of given by NBA or your Washington Accord, whatever statutory bodies have given us, this program outcomes for generalized 12 program outcomes. If you look into that, first 4 program outcomes will focus on your domain knowledge. Then if you look into modern tool usage, your communication skill, and third category, your finance, market, project management, lifelong learning, all these stuffs, individual and teamwork, this will focus on skills. And remaining aspects, that is designing a product which will not harm our society, how environment, to be an ethical person, having a lifelong learning, all these steps will focus on your career attitude or your behavior aspects. So you can divide this entire generalized program outcomes into 3 aspects. One which focus on knowledge, second one which focus on skills, third one which focus on behavior and attitude. So if this is going to happen, the curriculum aspect has to be revised, which will focus on, in addition to building the knowledge base, the focus is now towards skill and behavioral aspects. This is missing element in the curriculum. I cannot say it is missing, but the level of impact it is creating in the current curriculum is less. And if you look into the other aspect, our national education policy, they have also come out with a policy that we want to have a holistic development. A person who he should have a 360-degree development in all aspects. That is required for a holistic approach. If you consider the engineering curriculum, the holistic approach, I have looked into 3 aspects. One is employability, second one research and higher studies, third aspect will be entrepreneurship and innovation or campus startups. This is how it will be measured in the future years. So that is why a holistic approach is required when you design a curriculum. And if you talk about multidisciplinary education, the idea of multidisciplinary, now, if you consider one specialized branch, for example, if I'm considering civil engineering or if I'm going to consider as a mechanical engineering as a specialized branches, the days are slowly vanishing where we have an exact boundary for mechanical engineering, exact boundary for civil engineering. And down the line, another 15 or 20 years down the line, we are expecting that we'll have a single word called engineering. So it will encompass for the first 2 years, majority of the people will have a common engineering study and some specializations will be done in the later part. This is what the expectation for the national education policy also looking for it when you look into the multidisciplinary approach. So the boundaries for individual departments or individual programs are getting vanished nowadays. So for example, if you consider a mechanical engineering guy, he should know something about IoT, he should know something about cloud computing, he should know something about blockchain. All those stuffs are required to survive in this era or in the future eras. So this is why this topic is becoming important, why we need to restructure our curriculum towards holistic and multidisciplinary education. And my content will be like this. I want to give how we design our curriculum, what are the components or the factors to be considered when you design a curriculum, OBE based curriculum. Second, what is the AICTE guidelines available current at present? and what are the requirements of national education policy requirements. Based upon these things, this becomes one of the input for designing your curriculum. Second thing, what are the skills required for future engineers? Many forums give what are the future skills. For example, if you consider NASCOM, they have come out with the future skills for next 5 to 10 years. These are the skills required from engineers. Similarly, if you consider world skills, they have given us a lot of skill aspects which has to be our skill set for the engineers has to be increased. For if you consider engineering, it is a course where we do hands-on practice and learn something. So this practice-oriented approach is required, which will enhance our skills. So this part, a lot of focus is there. So one is requirements given by the governing bodies. Second one, future skills required for engineers. Third thing, as the national education policy demands for holistic development, I take 3 aspects. One is employability. Second one, research and higher studies, what are the requirements, and innovation and startups. Your curriculum should have a pathway. If a candidate is looking for an innovation and startup, your curriculum should have some basics for if a person is looking for research and higher studies. These things has to be inculcated, and we should give a provision for self-learning also. How we are going to do this, that is all about holistic development. And as I pointed out, the boundaries for engineering is getting vanished. So multidisciplinary education is going to be the order of the day. So we need people who have some expertise in programming, who have some expertise in pushing the data to the cloud and do some computing and get back do some analytics, and he is able to interpret what is happening in the factory with his mobile phone or any gadgets or laptops. That is required. So you need it. We are expecting that in the future, the AR and VR, augmented reality and virtual reality, will take over. Even when you are going to buy one product, you will be in a position to visualize it, what are its effects and how it looks like. All those steps will come. That is the expectation. So the cross learning from cross disciplines, across the disciplines, is going to be the order of the day. So how to take that into account, because we cannot all of a sudden start it with a big bang. So slowly we should inculcate this culture. Maybe in the first regulation, you may have introducing few multidisciplinary courses. Down the line, it can be a part of your majority of your electives in the first initial stage. Later part, it can move as one of your core subjects. This is how this is going to happen in the near future. So for all these, taking into all these account, I want to give some example about how we have designed our mechatronics curriculum for regulation 2022. And I want to give some concluding remarks on what are the things we have discussed. This is how I'm going to present for the next 1.5 hours. So let me take few moments to discuss something about outcome-based education. So if you consider outcome-based education, as I have pointed out, it focuses on, instead of focusing on outputs, we are going to focus on the outcomes. Outcomes means I'm going to talk about knowledge, how much a student has acquired and how much he is able to demonstrate. That is the thing I want to convey. So first thing is knowledge. Second thing is skill. Skill, I mean that, for example, if you are going to expose him for a CAD package or some MATLAB programming or coding for using any languages, if you are going to do that, I call it as a skill. So skills are required. Let us discuss about the skills elaborately in the future slides. And third thing, your knowledge and skill, you can immediately see what is the effect at the end of your 4th year or year after completing the graduation. But if you want to demonstrate, if you want to identify how much our curriculum has focused on changing the behavior and attitude of the students, it may take time. it may take them 2 years, 3 years down the line. If he is able to exhibit this ethical behavior, working in a team, he is able to adapt to it. Okay, if all these things, if he is able to communicate properly, all those stuffs, okay, will be explored in the later part of the thing. So according to my knowledge or according to my thought process, I classify the outcomes into only 3 broad categories. One is knowledge, second one is skill, and third one is your attitude or behavior. So our curriculum or OBE focus on what the student should need to learn in the future to survive in this world. Second thing, what the student should demonstrate to the professional world. So it should answer to the 2 questions. When I'm designing a curriculum, what the students need to learn. Second thing, what the students has to demonstrate to the professional world. These 2 things are required. So accordingly, we will design our curriculum, we will design our delivery mechanisms, we will design our assessment tools or methods to identify your competency of the students. So this slowly, already we have shifted from output-based education to outcome-based education. Majority of the colleges have started to focus on it and they are doing good. But still it is required because people talk about gig economy, okay, multidisciplinary approaches, holistic development. These are still a long way to go. That is why designing a curriculum towards this has become a big need for the need of the hour. So if you consider people are talking about outputs and people are talking about outcomes. Let me clarify on these 2 words. One is output, that is within the control of the program. For example, if the mechanical engineering course is designed like that, you can expect this is the output I am going to deliver. This was measured based upon the marks they have scored or the percentage they have scored. Graduation rate was taken into account. Okay, your placement was taken into account. Higher studies were taken into account. But outcome-based education focuses on the other three aspects. Okay, it focuses on your knowledge level, how much he has acquired at the end of 4-year course or 3-year course, whatever be the format of the course, how much knowledge he has acquired. Okay, second thing, what are the skills he has developed during the course of study, and third thing, how he is behaving, how he is making himself ready to face the society. These things are, I call it as outcomes. So outputs are generally your immediate effects, results after the completion of an activity. For example, if you measure your weight using your weight bands, okay, your weight immediately as soon as you stand on the device, you are able to get the exact weight. This I call it as output. But if you consider the person who is continuously taking exercise, like going for gym, and if you want to reduce his weight or if you want to make himself fit, it won't take one day activity, it cannot be completed. It takes a period, it takes a certain time. Okay, so near future this is going to happen. It is measured between some point in the short term to medium category. Okay, so it takes some time to make himself fit. So this outcomes generally speaks about the behavioral changes, skill acquired, and the knowledge thing. Your outputs relates to the change in your abilities. This is how I consider the difference between outcome and output. Output is within the control of your program. Outcome is not in the direct control. You need to build it over a period, then only you will get the fruits out of it. Okay. As earlier speakers might have discussed, your outcome based, if you have decided that you are going to follow outcome based education, the first step will be designing a curriculum which a student has to undergo, okay, based upon the majority focus on the attributes. So generally your program outcomes, 12 outcomes, Generally, we classify based on the keywords. We take it as graduate attributes. So if you focus on these three things, you will be getting what are required to build a technically sound engineer. Okay. Now the need of the hour is to produce engineering, not engineering graduates. We need to produce engineers who are ready to take up the challenges, who are ready to able to comprehend what is the problem available and able to find out some solutions. That is required for, if you consider the outcome-based education itself. So first step will be designing a curriculum which suits your outcome-based education. So second thing is, the later part, maybe in the future, speakers will be covering about outcome-based learning and teaching methods and how to assess in the case of outcome-based education. And my focus today is on this setup, that is how to design your curriculum in order to make your students to be competent enough. Okay, let me pose one question to the audience. When you want to design a curriculum, what are the factors you will consider? Can I get some answers? If you want to design a curriculum, what are the aspects you will consider?
We will consider the industry feedback, sir.
Very good, sir. Industry feedback, first thing, then
Feedback from alumni, sir.
so stakeholders.
Yes.
Let us put it in the feedback from the stakeholders. It includes employees, it includes alumni, it includes current students, and to some extent, if parents are capable enough or working in this area or in this domain, they will be in a position to help you out. Okay. So apart from this, how will you start to design a curriculum?
Like that also, I think my feeling is that also depends on the vision mission of our institute, what we are aiming in the long run of our institute.
Okay. One input is your vision, mission statements, and program outcomes
Educational objectives also.
and program educational objectives. This comes into picture. This is one part. The other side, feedback from the employees, stakeholders. Then the institute maybe to focus on certain aspects. It want to develop certain competency among the graduates when they are moving out of their college. Okay, this can be one aspect.
Maybe in the larger
curriculum
sense.
The curriculum should be, I think, framed based on the achievement of the POs, 12 POs, how we can achieve in the 8th semester.
That is 8. How to focus. If you look into the NBA accreditation manual itself, when you look into the curriculum design aspects, how our curriculum is able to make, or we are able to design a curriculum which will meet out the program outcomes. Rightly said, sir. Any other aspects?
In the larger extent, maybe we can think of global sense, like sustainable development goals and all have come into the picture.
Very good.
That also maybe we can think of it, and then how we can incorporate and how we can see this the 21st century skills and all those things, how our students can meet those requirements. So considering all those things, we can go ahead with that curriculum.
Yes, I certainly agree with this point, and let me come back to my presentation. So our focus is towards developing an outcome-based curriculum. So to get into curriculum, I think let us understand about the framework of OBE, then straight away let me move on to the curriculum design. And as everybody has pointed out, you need to get the feedback from the industry and professional organizations. Normally, professional organizations, let us there is one word called lead societies. If you consider mechanical engineering, we used to say that American Society of Mechanical Engineers as a lead society for us. Similarly, if you consider EEE or any other thing, IEEE can be a lead society. If you are into biomedical, your American Society of Biomedical Engineering will help you out. So lead society will identify what are the skill set required for you. Similarly, if you consider India, NASCOM is also doing this job. They have already identified, if you browse it, you will get NASCOM future skills. So this also gives a broad outline of what is required. So based upon that feedback and everything, as sir has pointed out, institution also plays a major role. What is your vision and mission? That is also taken into account when you design your curriculum. So PEO, that is program educational objective, down the line, how much he is able to exhibit. As soon as a graduate is moving out of the college, next 3 to 4 years or down the line 5 years, how he is behaving, and during this 5 years, what do you expect from the graduate? That generally we call it as program educational objectives. If this is also met, this has to be met one way through curriculum, the other way is through their knowledge and experience what they are getting over a period. That is also going to help them. Then it becomes your outcomes. It can be knowledge, it can be skill, or it can be behavioral change. These aspects to be focused. Based upon this, to meet out these things, we need to identify the courses. So if you consider first 4 students' outcomes or program outcomes, it focuses on fundamental engineering, then it focuses on problem identification, solution identification, and analyzing the system. All those aspects is required. So based upon that, you build upon the courses required to meet out these things. Then look into the skills. What skills a mechanical engineer has to exhibit? Or if you consider a civil engineering student, what skills he should exhibit? I'd list out the skills. Like one is knowledge or technical professional competency. That is purely focused on the aspects of your lead societies. Lead societies will give you a broad outline what is expected from a mechanical engineering graduate. Collected. Second thing, identify the future skills required or to be exhibited by the graduates of that particular domain. And third thing, as a common thing, we as an engineer, as a human being, what are the values, life skills we should possess in order to survive in the market or to survive in the society that is required. So based upon this, you plan your courses, you plan your syllabus content, you plan your teaching methods, you plan your learning activities, assessment tools, all those things. And again, go for course assessment, program assessment, then maybe PEOs in the later part. Down the line, another 4 to 5 years, we should measure our program educational objectives also. If there is something has to be improved, it is a dynamic in nature. We cannot confine that, since the requirements is changing continuously. We cannot confine to a particular period alone. It cannot be a static statements. Remember that your vision, mission statements, maybe vision, you can look for another 5 years. Mission can be varied to achieve your, maybe in the first year, if it is not working, you have to change your mission statements in order to achieve your vision statement. Some strategies or steps we have to modify, means some improvements has to be done. This is how an OBE framework will work. So coming back to curriculum. So curriculum defines you the knowledge, skill, and attitude the learners are expected to acquire during the course. It gives us the entire package, how the total courses are defined, what are the things they should study in a curriculum. Why it is important means it decides the quality of the graduates. How he is capable enough to meet out the requirements of the industry. Second thing, our curriculum should provide a space for them to learn by themselves and keep on learning. So learning is a never-ending process that should be there. Our curriculum should define this way of enabling them to learn by themselves, so that they make them as self-enablers. And third thing, most of our curriculum nowadays focus on first two aspects. They are able to do it, but the last aspect has to be taken in when we are designing our curriculum in the near futures. So holistic education implementation is required. So some avenues for fun with learning, physical activities, values and ethical process has to be brought in. Slowly, ethics and human values we are talking about, but we are least bothered about the sports and other physical activities. These has to be brought into our curriculum. Somehow we have to identify what steps. This is again third aspects. I take holistic. Currently, we are looking holistic development in the form of enhancing our employability, enhancing or providing ways for or means for people who are looking for research and higher studies. And last one is campus startups. Maybe slowly in the later part, we can also have a curriculum which provides a provision for sports and physical activities also. If these things are brought in, then we'll be in a position to get into the holistic development. So in general, when you design a curriculum, generally we start with the learning objectives. So what are the things expected to be met? That has to be defined, jot it down. Okay. Once this is done, then you define the syllabus for it. Then how we are going to do the assignment parts, bring the assignments into the curriculum. Projects, what we are going to give for mini projects or capstone project, or a project which normally takes 6 months, 3 months, depending upon the cases. Okay. So if you are starting his idea from first year onwards, if you are able to build over a period, okay, if it passes through first semester, second semester, third semester, if he's still holding on this idea and he's nurturing it and he's making modifications, he's able to come out with a proof of concept, then moving to prototype stage, then coming to minimum viable product. All these things, if it is happening, then how do we provide provision for capstone projects? This generally, if a project is taken from first semester or from conceived from third semester onwards, and if he is taking continuously focusing on it, we should provide a provision for him to inculcate all those aspects and continue the idea for period, because startups cannot happen in one day. If you look for your aim as to have campus startups, okay, he has to dwell on this idea for at least 1 year or 2 years. Then only at the end of the fourth year, you can have campus startups. If this is going to happen, how we are providing provision in our curriculum, that is required. So these are the factors to be considered. Your assessment method, your books and materials, assignments, what you are going to do, all those things you have to decide when you are designing a curriculum. Generally, the key components of any curriculum will be foundational theories, mathematical basis, analytical problems, design principles and tools. Once they are familiar with these 4 parts, then they should be exposed to real life problem statements. They are able to identify a real problem, which is there. If you are able to identify a problem where it is a problem for majority of the people, and if he is able to narrow down the pain points, then there is a business for him. So campus startups can flourish. Then your application areas of your course. So normally, if you consider a 4-year graduation means, first 2 years, your fundamental first 4 parts will cover. That is foundation theories, mathematical basis, analytical problems, design principles and tools has to be covered in the first 2 years of engineering curriculum. Then you should expose the possible application areas of your course in 3rd year and final years. And in the end of your final year or during the final year period, 7th and 8th semester, he should be able to identify what is the problem. He has to define a statement. He should observe the pain points of the people. He should be able to comprehend it. Then he should develop a problem statement. For that problem, he should be in a position to arrive at the solutions. This is what expected from a curriculum. So if you consider typical world-class curriculum, early days past, it was only foundation, theoretical and mathematical approaches were followed. Currently, we are following mathematical application development, problem-based, solution-oriented curriculum. We are following it. Future, the focus is we require our curriculum to focus on entrepreneurial approach. So we don't want, you may arise a question that how can I make everybody to be an entrepreneur? We don't want to have so many entrepreneurs also. So, but the thing is, we want to have an entrepreneurial mindset. That is, if you conceive an idea, they should be in a position to commercialize it. Inventions will happen if you are adding some commercial aspect. If an invention plus your theoretical conceptualization, inventions are there, okay? If you are able to have a commercial value for it, and if you are able to add value to the customers, then it gives an opportunity to be an entrepreneur. So this mindset is required when you are going to teach for the next generations. So this is what the need of the hour. So entrepreneurial based, product based, innovation based approaches are required. So this will be the future. So we want to have people at the end of our curriculum or end of our 4-year course, people should be creative. They should do innovations at the end of their graduation. This is what required. And the impact, what is expected is, we will have campus startups at the end of the year, end of your graduation. Since if you look into the range of candidates who are moving to companies or getting employability, people those who are going for higher studies, people who are looking for entrepreneurship, now this is a big difference is there. For example, if we take 80 to 85% of the people look for employability, 10%, 5 to 10% look for higher studies and research aspects. Only 5% of the current graduates are in a position to take up entrepreneurial ventures. This has to be eradicated, and slowly this numbers, if it is decreasing, employability, people looking for employability, if it is reducing, okay, and more entrepreneurs or more startups, if we are able to produce from your campus itself, then that will be a success story. This is what expected from your curriculum design aspects. And let me come back to AICTE guidelines. AICTE recently has given out certain guidelines. If you look into those guidelines, the focus is on ability enhancement, that is skill enhancement. Second one, they focus on more open electives. Why more open electives? Any guess?
Open electives give cross-discipline courses, sir.
That's correct, sir. That is, they look for multidisciplinary approaches. Okay. So AICTE has given us this freedom, and they are asking us to have at least 18 credits in the 160 credit course. They are looking for 18 credits, but still, as a domain experts, there are a lot of debates when you decide, when you are going for curriculum design. People will not compromise on leaving the professional courses, core courses. When you consider early days, it was 180 was the credits announced by AICTE. Now they have reduced to 160. It gives them flexibility to learn by themselves, self-enablers. They are looking for to have people who can earn credits through self-learning. That is, they are looking to encourage online courses, NPTEL courses, MOOC courses, all those stuffs they are trying to focus on it. So that is how they have brought this from 180 to 160. But during this one, among this 160 credits also, Now the focus is on more emphasis on open electives. As Sir has pointed out, it gives an opportunity for them to look for multidisciplinary learning. That has to happen. And similarly, we want to have skill enhancement also, ability enhancement also. So they are also looking for us to give exposure for the young graduates to the real industry scenario, what is happening in the industry. They are insisting on 3 internships instead of 1 internship. So if you look into the internships, weightage is increased. So most of the when you are designing curriculum, if you're looking for curriculum change in the forthcoming years, maybe you can start the internship from 6th semester, 7th semester, and 8th semester. Some maybe 1 month internship in the 6th semester to start with, 2 months internship in the 7th semester, and 3 months or 4 months internship in the 8th semester. This can be thought of. So decide on this thing. So this gives an exposure for them to work in the real environment, like in the medical syllabus. People are taking up 1 year as intern and they are working there in the hospitals. Like that, we want to provide a space for our engineering graduates also. So this internship opportunities will help them to look into this one. And now AICTE has also advised us to go for looking for startup policy also to have into your curriculum. You can provide a break for them for 1 year. Okay, at the end, after that, they can also join your course. That is the freedom it has given. So explore it. I think recently BITS have come out with opportunity of giving 1 year period as a break, and they can take up the course. They can continue the course. Okay, for startup exploration, 1 year period is given as an exemption. So all these stuffs will help them. 3 internship. Second, they have made this courses as universal human value courses and certain mandatory courses like these are the courses mandatory: environmental science, induction training, Indian Constitution, essence of Indian traditional knowledges. These are made as mandatory courses. So you don't have credit, but they have to undergo these courses. They should understand the essence of it. Second, open elective in NCC is also given. In addition to cross-culture learning, you can take a course under NCC. You can work there and it can be credit. You can accumulate the credit. Yoga, sports, music, fine arts. If this is brought in, maybe it will take time for us to inculcate into our curriculum, but it has started in IITs and NITs. They have started to implement this national education policy, and they have brought in this credit course for NCC, yoga, sports, music, fine arts. All these things are brought in the recent curriculum. When I discussed with the NIT professors, they gave us a clue that they are into implementing the national education policy. So if that is going to happen, you can have open electives in these forums also. So again, biology for engineers in 4th semester, already Anna University has implemented this. Most probably, we will be in a position to have biology as a part of our engineering curriculum, because that gives a flavor of what is required if I am going to develop a product for it. For example, in our TBA, one biotechnology student came, and her name is Varshita from Hyderabad. She is diabetic, type 2 diabetic from her childhood. That is meaning is she has to impregnate her fingers thrice a day in order to monitor her glucose level, blood glucose level. So the pain point is 3 times a day you are impregnating your fingers with the needles. One thing. Second, as a middle class family, she has to spend at least 3,000 to 5,000 per month for testing her blood glucose level. So she understood the pain point and she came out with the solution of developing a non-invasive glucometer. She is about to get 93% accuracy she is getting. So most probably, if you consider, if you look into this product will, it has a need. That is, if you consider India, it is a country with the highest diabetic patients. So the need is there, desirability for the product is there. Second thing, technically whether it is feasible, they have done it. They have identified with a finger touch without blood. If you're able to identify the glucose level at the edges of your fingers and with the touch, they are able to identify it. And some more suggestions came with the breathing in and breathe out air. We can able to test the glucose level. That is also possible. That is somebody is also trying in RTBI. These are the things required. And third thing is, if you look into the scalability, this product, since it is a pan across India, most of the people are diabetic. In each family, you can get a diabetic patient. It can be scalable. So desirability is there. Technical feasibility of the product is there. Third thing is market viability or scalability is also available. Why I am telling this is, she is a biotechnology student, she is able to comprehend it. If a mechanical student or a mechatronics student or another instrumentation student is looking to this one, if you are able to identify what is happening, how the blood flow is going to happen, what are the viscosity and other properties of the blood, if you are able to identify, and if you are able to identify the methods to identify the glucose level in the blood, then biology becomes a major part of it. So they have introduced biology in the 4th semesters. This is also happening. And as we have discussed, from 180 to 160 credits, majority of the institutions have reduced it. And they have, if somebody want to have higher credits, they can earn through another 20 credits through honors or minor degree program. If they want to move abroad, because majority of the foreign universities look for 180 as the credits. If that is going to happen, 160 plus another 20 credits they should earn through either honors program or minor degree or through online mode of learning. This provision has to be given in your curriculum itself. Next one, 50% of formative and end semester review. This, as they have advised us, and blended learning has to be encouraged. Okay, maybe few cases you can get support from experts from outside. Some cases your teacher can help you out. In some part of your curriculum itself, they should explore it. They have to hands-on practice. They should get it. From that also, this experiential learning has to be done. They have to practice it. They should learn from this aspect. These are things expected, and these are the new guidelines from AICTE when you are designing a curriculum. So as the split up goes, 160 credits, 12 credits for your humanities and social science, basic science 25 credits, engineering sciences 24 credits, core, it is program core is 48, program electives 18 credits, equivalent to program electives. Now your core open electives are also suggested 18 credits. Then in order to provide a provision for 3 interns and project works, your capstone projects, minor projects, 15 credits are increased. This is the split up for AICTE. And if you look into the national education policy, in a nutshell, this is the one. So they look for this new structure, 5 plus 3 plus 3 plus 4. This is going to happen. And they're looking for establishing a National Research Foundation, which helps to, because our undergraduate students, the outcome related to research is very low. We need to boost up this one. So this foundation will provide a guidelines for us to inculcate the research culture among our students. And maybe Higher Education Council of India, the merger of UGC and AICTE will happen in the near future. This is what going to happen. Apart from this, to look into this one, your multidisciplinary and holistic education, conceptual understanding, then life skills, critical thinking, experiential learning. All these things focus on the next generation. So when you decide a curriculum for the next generation, keep this in mind. You should have a provision for multidisciplinary courses, holistic development, where they can take yoga, they can look for fine arts, they can look for sports, they can look for the music also, they can look into it. This has to be brought in. So multidisciplinary and holistic education, maybe when you are designing your curriculum for the another down the line, this will be the order of the day. So please look into this aspect. Second, life skills. What are the skills required to run your day-to-day affairs? This is also required. Then critical thinking. Now people talk about design thinking at the most. Okay, so try to have design thinking as a course in the third semester itself, so that they can conceive a right idea, they can identify the pain points of the people. So let them develop from that idea. If they are dwelling on that idea for at least 1 year or two, at the end of your third year and or in the seventh semester, they will be in a position to develop a product. And fourth year, if they are able to develop a prototype or minimum viable product, they will be in a position to get into startup category. So critical thinking and design is through design thinking is also required, and wherever possible, try to have experiential learning. So we have decided that in our college, we are going to have this experiential learning starting from the first year onwards. Slowly, we have 2 papers in the first year, that is workshop practice 1, workshop practice 2. It was traditionally, they're looking for some work in electrical engineering, they'll be studying some experiments in electrical, they'll be having some exposure in the workshops of mechanical engineering. These 2 combined, they'll be having as the workshop practice 1 and 2. Now, after looking into the world skills, we have introduced some 8 new skill sets, and these skill sets, how we are planning is, first 4 skill set they should acquire in the first semester, and the next 4 skill set they should acquire in the next semester, second semester. Each candidate has to undergo, for example, let us take additive manufacturing or 3D printing. Each candidate has to design a small component. He has to print it using a 3D printer. Okay, so he is learning, designing, and he is able to produce it. And for different at the end of 5 days course, first 2 days the teacher will help them, and third, fourth, and fifth day, each candidate separately has to develop a design, small component. He has to design, prepare in the CAD software. He has to import that CAD software model to your 3D printing machine. Then he has to develop a small prototype of the component. That is taken for the first lab skill set. Similarly, 4 skill set in the first semester, another 4 skill set in the second semester. So at the end of first year, he will have some exposure to what is all about engineering. How I can coin up, design a product, how I can manufacture it. For otherwise, if you consider web applications, web design, we have introduced as one of the skill set. He has to program it, he has to develop the codings, he has to launch it. So web page he has to develop for a small application, for a small company, that is required. So this is how we have done it for experiential learning. So slowly, here also we are moving from the conventional practices to experiential based learning methods. We are trying to incorporate, and slowly second year, third year, and final year, majority of your curriculum, we take it as your approach should be conceptual teaching should be there. At the same time, they should have a hands-on practice. This is how we are trying to build our curriculum. This we are taking it seriously, And in the 2022 regulation, the current regulation we have formulated, these things are incorporated. And the other aspects, if you can look in multilingualism, as the recent days you might have seen in the medical course itself, they have developed in books for medical field. It's coming in their own language. Hindi, they have tried it first. Maybe in future, already in Anna University, we do have a Tamil, Arrivial Tamil as one of the paper in our first year curriculum. They're slowly bringing multilingual part, because if a candidate is learning in their mother language, they will be in a position to understand it. They can understand the concepts easily. They can build upon it. So that is the idea. But how it is going to work, we have to look into it. They are trying it out. This will happen. And so to decide a curriculum, first thing is statutory body guidelines. One is I have considered AICTE. Second one, National Education Policy. And before getting into third thing, it's all about graduate attributes. What you have told is program outcomes. So if you look into these things, engineering knowledge, problem analysis, design and development of solution, conduct of investigations on the complex problems, all these things requires your domain knowledge. If you are a mechanical engineer, you need to have in-depth knowledge in your fundamental courses. Then only you will be in a position to analyze a problem, develop a solution for it, and if you are able to modify the variables, what is the outcome you are expected, all those steps you can explore it. So first 4 POs, okay, are generally cognitive in nature. That is, it is related to your mind, it is related to the knowledge. Okay, if you consider next 3, that is modern tool usage, individual and teamwork, communication, project management and finance, these all things speaks about skill. Suppose if you are teaching control engineering, if you are exposing the candidates to modular system, okay, if you are able to develop the design of it, if you are able to develop a model, that is CAD model of it, you can import the CAD model to MATLAB part. You can identify the transfer function of it. You can identify the response, how quick the system is responding. All those steps you can inculcate with the help of your MATLAB tool itself. So this modern tool usage is a skill, that is exploring candidates to programming or coding skills, communication skills, and your software exposures, tools, what you are going to use. Okay, if that is generally fall in the category of psychomotor domain. And last case, engineer and society, environment and sustainability, ethics, lifelong learning. These are your behavioral change. So all these things are affective in domain. If you can start, they fall in the category of affective domain, and it's all depends upon the behavior or attitude change that a curriculum will inculcate in the students. This is how graduate attributes are defined. You decide how much is required for these aspects. Okay, what are the courses required? So you cannot compromise on the fundamental concepts. This is required. In addition, what are the skill set you want an engineer should possess? And similarly, over a period, what are the behavioral change you expect in the candidates? That has to be slowly brought into the curriculum. So skills create opportunities, they connect societies, they are the foundation for economic progress of any country. And if you consider world skills, before getting into world skills, generally we take these are the 15 skills required most wanted if from an employer perspective. Knowledge, engineering knowledge is communication, planning, quality orientation, the general knowledge, teamwork, analysis and judgment, customer focus, integrity, continuous learning, innovation, cultural adaptability, safety awareness, professionalism. These are the things they require. And let me give some exposure to world skills. Hope few may be aware of it. So if you consider world skills required for the next generation, or skills required, they classify into these broader lines. That is, if you look into what kind of skills you are interested in, being creative, okay, if you look into this aspect, creativity can be done through all these things. That is 3D digital game art, your architectural stone masonry, that is also required. Normally நம்ம ஊர்ல சொல்ற மாதிரி கற்சிறைகளை செதுக்குவாங்க, those people, okay. So this is also required. Bakery is a skill, beauty therapy, cabinet making, cooking, fashion technology, forestry, graphic design technology, hairdressing, industrial design technology, jewelry, like this, the list goes on. So wall and tile fitting, that is also going to be it is a skill. When you look into construction work, like placing a tile, you need a skilled labor. Everybody cannot do it. So this is also a skill according to world skills. So this is all about being creative. Suppose if you want to talk about complex problems. So if you look into the complex problem category, your additive manufacturing, aircraft maintenance, bricklaying, CNC turning, milling, cloud computing, chemical laboratory technology, cyber security, digital construction, electrical installations, electronics, industrial control. These are related to complex engineering problems. So all these steps, Industry 4.0, manufacturing, mechanical CAD, IT solutions for business, networking, cabling, information cabling, networking of your systems, your mechatronics, mobile applications, mobile robots, all these stuffs will fall in the category of complex problems. Similarly, craftsmanship required, somebody to fix some problems, you require people, skills required. To help people also, we need some certain skills. To look into this aspect, okay. So helping people, it speaks about body repair, that is car shops, auto repair shops, beauty therapy, cyber security, we need to have for helping people, like hairdressing, all those things. So I request everybody to get into this world skills and check what are the skills required for the next generation of the people. Why they are having normally world skills conduct a competition or national skill development people. Our country is one of the part of this world skill competition. Every year it is conducted, and our country, they have around 40 countries those who are enrolled here. India is also one of the member. Okay, so every year the competition is conducted. They want to groom this one skill sets for the next generation. So majority of our engineering graduates, for their skill set, they can identify their domain, they can connect with certain experts in throughout the world, they can come out with certain participate in certain competitions, they can bring laurels to a college as well as for the whole country. The competition is like this. They start with the district level. National Skill Corporation takes care of this one. Second thing, they move to state level competition. From state level, national level competitions is conducted. From those selected based upon the skills, people are selected and they are sent to the world skill competition. So if you find time, please go through this one. This will give a brief about what skills set you can expect from the engineers for the next generation. This is one forum I want to introduce you. Second one is all about NASCAM. So NASCAM, they have identified certain skill set for the engineers. Okay. So future skills, again, their focus is on this aspects. So if you consider what are the skill set they have identified, okay, so we can have a lot of exposure in this one. Let me put it, I've already given in the slide. Let me quickly go through it. What are the skill set required? According to NASCAM, these are the professional skills required, starting with continuous learning. This already it is in our program outcomes. Any program or any event or any project, if they have taken, they should be in a position to manage it. They need problem solving as one of the professional skills, product management, communication, and storytelling. Storytelling is important if you want to market yourself or market your product. You need to develop a story for it, then only it will reach the end users. So storytelling and communication is a major part. Days are gone only focusing on communication. We need people who can narrate a story, who can pitch the story to somebody, who can raise investments. This is all required if you are looking for people to be a campus startups. So design thinking, it's again another tool required for identifying the pain points of the customers, empathizing what others feel or what are the pain points of others, then developing a solution for it. So design, there are a lot of tools they are discussing in design thinking. This is also required professional skills. They fall in the category of design thinking, falls in the category of professional skills, project management, negotiation and influencing, digital leadership, collaboration. So you need to collaborate with different technologies. Similarly, you need to collaborate with different people. These are the stuffs required to be a professional skills. And NASCAM has also identified few skills or few technologies, emerging technologies. Already we have discussed something about virtual reality, cloud computing, 3D printing, AI, artificial intelligence, Internet of Things, your big data analytics, mobile technology, cyber security, robotics, and process automation. This is all required. So why I am telling is, try to have 1 or 2 courses in each semester for these emerging technologies, so that your elective, let us start with introducing the elective, and if somebody is really interested, let them take an elective in the 5th semester. If you want to continue, let him move to open elective category, let him pursue from the other departments next advanced level of learning. Start with basic level in your department in the professional electives, then introduce them or provide a provision for them to take up these technologies across the domains, so that multidisciplinary approach can be brought in through curriculum. So this is what I want to say. So these technologies, maybe for example, if I'm dealing with mechatronics engineering, we will start with 3D printing, then we'll be talking about AI, before that Internet of Things, AI, then comes your big data analytics, okay, virtual reality, and to some extent cloud computing and mobile tech, because robotics will form a part of this regular core subjects. The remaining subjects can be introduced as a professional elective, and still if they want to have in-depth knowledge in AI, they can move across the departments. They can learn from other departments like computer science, IT, or electronics and communication, or AIDS. They can learn if they are still having a thought for it. Okay, this is what introducing or providing a provision for emerging technologies. This is all required. And the other thing is about lead societies. So each and every lead society has already identified for their stream what is required, what are the minimal requirements from the graduates of their streams, they have already defined. We can get into this one. And ABET also has come out with this policy. If you look into ABET, so they have given the criteria for accrediting engineering technology programs. If you look into the curriculum aspects, so what are the students' outcomes? They are based upon your program outcomes. They have narrowed down to 5 attributes. But for curriculum, if you consider, so first one is mathematics should be a part of your engineering. Okay, that should be the base on which we are building the thing. So mathematics forms the basics, then discipline specific content. So for example, if you are dealing with mechanical engineering, your core papers like thermodynamics, your heat and mass transfer, your engineering mechanics, strength of materials, design part, your thermal part, and manufacturing part. So this is required. So first is mathematics. Second one is discipline specific contents are required. So next one is other contents. Here other contents involves, if you look into this one, the curriculum should include topics related to professional and ethical responsibilities, diversity, inclusion awareness, quality and continuous improvement. And in addition, but is also specifying us to have an exposure on physical and natural sciences. This is how our education system has brought in biology as a core paper for our engineers. So we need to have some exposure related to physical and natural science, and this is also required. Then integration of content. Your integration of content, I mean that this will help them to improve their skills. For example, there may be technical skills required, there may be non-technical skills are required. When you want to have develop a competency of the students, they should be in a position to integrate all these skills, then they should be in a position to solve it. Then cooperative education, this is again another criteria. And based upon this, you decide your advisory committee for your thing. So this is what ABET has also given about curriculum aspects. So when you define a curriculum, please take into account these aspects. That is guidelines from AICTE, guidelines from National Education Policy. Third thing is future skills. You may look into world skills or you may look into NASCOM to identify the skills. And finally, look into the ABET also for curriculum design. What are the basic things they want you to have in the curriculum? So it is according to them, it is a combined. The curriculum must combine technical, professional, and general education components in order to support the student outcomes. So this is mandatory. So once, if you have decided all these things, if you have gathered enough inputs on these aspects, then look for holistic development. So I have defined holistic development from 3 perspectives. One is employability, that is logical reasoning, analytical reasoning, communication, personal development, that is soft skills, and technical skills. These are required. If you look into research skills, starting with formulating the questions, observing what is happening in the system, planning it, collecting data, recording the data, organizing the data, interpreting the data, and presenting your findings. These are required. All about these skills. And last case, if you want to have your people or you want to have campus startups, these skills are also required. So you have to inculcate a passion for anything. So a fire in him, which will start from second semester. If you are able to nurture capstone projects, that will help them. Okay, perseverance, resilience to bounce back. You should teach him how to bounce back if there are failures. Okay, proactiveness, right attitude, willing to learn and unlearn and relearn, and how to deal with people. Okay, all these steps are required. These traits has to be brought into your curriculum itself. So generally, if you talk about innovation, They should have a sound knowledge to conceptualize their ideas. So theoretical conceptualization is required. Some innovations or newness is required. And if there is some commercial exploitation, you can do it, then it becomes an innovation. That is the difference between invention and innovation. Invention, it is all about finding new things. Finding new things may not have a market. All new things may not have a market. If they have a commercial value, automatically that becomes your innovation. So invention with commercial exploitation, with a sound conceptual design, it will lead to innovations. These innovations should happen slowly from your first semester to 7th semester or 6th semester. From 7th semester onwards, he should be in a position to validate his idea. Then only you will get startups at the end of the year. And this slide will help you to identify why it is required to focus on hands-on practice or skill building. If you read or hear, only 10 to 20% is retained. If you view images or watch videos, 30% is retained. And if you visit, exhibit, or watch a demonstration, 50% can be retained. And if you're looking for design collaborative lessons or participate in hands-on activities, 70% is retained. And if you're able to model it and simulate it, and you can feel the experience, and you can do it on a real thing, if you're able to apply it, then 90% of the content is retained. So this is how our engineering stream has to modify their curriculum. So with this note, I advocate the framework given by NITTR to develop a curriculum. Okay. So first thing is, as we have discussed, engineering and technology specific skill set, what is required, what jobs a candidate or your engineering graduate has to do. So what is the job market, what are the skills or competency or demands in the market, identify all these things, look for research and innovations, what is required, emerging new skill set, what is the thing required. All this should become your expectations or aspirations from a proposed UG program. Once this is done, then compare it with your existing curriculum and syllabus, identify the gaps, okay, benchmark with the lead universities. Normally we do with our parent university, we do with universities abroad, okay, to benchmark your curriculum. So do that. So one is identify the skills and jobs required or expectations required. Second thing is benchmarking with your syllabus and curriculum with the available best ones in the industry. Then identify, include your AICTE NBA guidelines, expectations, industry and employees expectations, gaps, identify the gaps in the skills and content in the current curriculum, go for new curriculum and pedagogy methods, then go for teaching and learning process. This is how it will happen. So try to have credits and introduce flexibility, have at least 3 internship in your curriculum, develop project contents, wherever possible, try to bring in industrial expertise to teach a part of your curriculum. That will enhance the exposure. 3 internship will also help them to have feel of industry, what is happening. Then try to have your different methods of teaching, learning methods. Maybe in the next few talks, you will be exposed to different types of classroom teaching and pedagogical methods. Use it, okay? Then you develop a detailed curriculum. So it should have course outcome, unit outcomes, contents, specifications table, what specification table, what is required, resources, what is required, then POCO mapping. This is how a curriculum has to be designed. So start with analyze, design it, and develop it. Okay, so it is a continuous process. You cannot, once if you have done it, it is not the end. Since it is dynamic in nature, the market is dynamic, requirements is also dynamic, skills expected from a graduate is also becoming changing day to day. So automatically you have to do a closed loop mechanism. you have to redefine all these aspects once in 2 years or 3 years down the line when you're going for curriculum development. So I'll go with maybe another 15 minutes to 20 minutes. I'll be, until now, if there is any questions, I'll be in a position to answer it. Any questions?
Sir,
Yes,
you have insisted on including a course on biology.
Yes, ma'am.
Is it like already we have environmental science in the curriculum, existing curriculum, or it is different, sir? Why
It
are
is,
you
it is
insisting
different,
on
ma'am.
it?
If you look into the syllabus given by Anna University, you can understand it. So biology aspects, we look into the life science aspects. So how the human being human psychometry is there? Okay, what are the aspects and what type of diseases recently we are facing? That has to be also, for example, if you study about the impact of corona and what other implications, all these things that has to be brought into our curriculum. So one is maybe first 3 units may be based upon the our human anatomy and what are the diseases that is we are facing and what are the remedials available. The next few things may be on the future technologies. This is what our curriculum in biology says. So try to introduce students to the so that in that domain whether they can explore a possibility of giving a solution to those diseases or those problems which occur in the biological or in the nature. So that is what it is all required. For example, let me give an example. In general, nowadays, peacock entering into agricultural farms is becoming more and more cumbersome activity for the farmers. Peacock, its own behavior, since we are not, since it is a national bird, none of our taking that, we should not kill it, we should not do any harm to it. So it is becoming, the population of the peacock is increasing and it creates a nuisance to the farmers. So if a graduate from an electronics and instrumentation or electronics or from a mechatronics, if they're able to identify a device or come out with a solution for it, that will help them. So they should understand how a peacock will react or how a crow will react, how a bird will react, okay, to what type of, there is always a practice in the birds such that if they are dwelling on a environment for 6 to 12 months, they adapt to the situation. This behavior they should understand as a engineer who designs a solution for it. So wherever possible, it is left to you. It can be your local problem statements in the last unit of your biology, or it can be a national problem or a worldwide problem can be taken, and you can expose them to those problem statements so that these students can come out with a solution accordingly. So that is the idea of introducing biology into the curriculum.
Okay, sir. Thank you, sir. Thank you for your explanation.
Sir, any other thing?
Sir, one more doubt I'm having, sir, regarding the curriculum development you have mentioned,
Yes, sir.
credits and all. So now the AICTE is slowly insisting to have that universal human value in the induction program. Earlier, they have insisted for the Tier 1 colleges to have that universal human value compulsorily as a part. Now, 1 month before I come across that, they have created 8 modules. Actually, they have planned to come each and every module in each semester, actually. And also, they have come out with some credit value also. Any idea about this, sir? Whether
sir.
because you are coming with the 2022 regular curriculum. So, any idea about that, sir?
Yes, sir. Time being, we have also introduced only one course as a non-credit mandatory course. in universal value, human values and ethics. So universal, why this is required? You know that the recent happenings in across the world and across India, we need to have graduates who can look into the behavior, the ethical behavior. Like when he is going to design or when he is going to develop a solution, it should not harm anybody. Similarly, for the entire graduates nowadays, a lot of issues are coming because of the social media and the exposure to the other electronic gadgets. So unless otherwise we teach them the morals and ethical behavior and ethical values of our Indian system, we will be lost. Our graduates will be lost. Maybe this may be one of the reasons why AICTE is taking utmost care to insist this as a mandatory course for the engineering students. Slowly, as you have pointed out, from one course to now they are making it as 3 to 4 modules. They are trying to have it as a non-credit course in all the semesters.
Sir, here I would like to mention, because I'm the Universal Human Values Coordinator from the for the university.
Yes, sir. Go ahead, sir.
That see, UHV 1 is the part of our student induction program. It is a mandatory, and UHV 2 should be offered either in the second semester or third semester, fourth semester, before the fourth semester, and that is a mandatory. So AICTE is saying that is mandatory, but all the other modules, as Gauri Shankar sir asked, so like understanding human being, now it has been released now. So if somebody wants to do that course on their own, they can do it, but they didn't make it mandatory. But whoever wants, like they are interested in that, if they do all these 8 modules, they can be given as a minor degree, like that they are saying.
Credits,
Yes,
they
sir,
can
sure.
earn extra credits.
Yes,
And they can
extra
do.
credits.
Yes,
If they earn, then you can give, university can decide, yes, this boy has done 8 modules, now we can offer him a minor degree. So that has to be taken decision at the university level. Otherwise, they are not mandatory. Mandatory one is that UHV 2, okay, for the students.
Okay, yes.
But at the same time, the faculty also should be trained to teach that subject. Just like that, anybody cannot teach that subject. So first of all, that values, that faculty should know, and he should undergo I think minimum 2 courses of that. There are modules in that AICTE 1. Then only they are eligible to teach that subject. Okay.
Yes, sir. Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you.
So shall I proceed, or any other queries are there? Or any point for discussion among us, we can take it up. I think if no more questions, let me introduce about multidisciplinary course called Mechatronics Engineering. So I belong to Mechatronics Engineering, and I served as a head HOD of Mechatronics for the 10 years as a head of the department. And since our college has got autonomous in 2007 itself, I was a part of 3 or 4 regulations which have undergone in the mechatronics curriculum. So slowly, already it is a multidisciplinary course, and slowly we have introduced open electives. From 2007, we have changed a lot, and we have introduced a lot of courses, new domains, and similarly, new way of teaching. All those steps we have brought in, and this curriculum 22, we have given more emphasis on skill building. So wherever possible, we try to have 1 credit, 2 credit, 3 credit courses where we can bring expertise from industries and teach them the fundamentals. So it will be hands-on training. And in some cases, we take up the credits given by international certifying bodies. For example, if you want to have an expertise in software, CAD software, we ask the students to undergo training for 50 to 60 hours. Then they should appear for the international certification course. What are the credits or the accolades they are earning from there? It is brought into our credit system, and equivalency is given for them, and they get trained. Similarly, MATLAB programming and the modules in the MATLAB, we expose them to make them a skill-oriented person. We made C, C++, Java, Python, and data structures is a mandatory course for all the engineering graduates, because we cannot say no more. There is no boundary for engineering. We cannot confine ourselves to this domain alone. Generally, mechatronics is a branch which focuses on building intelligent machines. The focus is, it is a science of intelligent machines. So if you want to develop intelligent machines, we focus on major 3 areas. One is sensor technology. Second one, we focus on control engineering. Third thing, we focus on actuators. So sensors, the whole syllabus or the whole concept of mechatronics evolves between these 3 elements: sensors, controllers, and actuators. If this is going to happen, so I need to build a machine which is very intelligent. It should be an intelligent machine. If that is there, I need to push the data into the cloud. I need to first fetch the data, then put it in the cloud, do some analytics, then it has to return back to the machine. The controller in the machine has to make a decision. It has to actuate something. It can be either electrical actuation or mechanical actuation, whatever be the case. So this is the essence of this course. This is what this course expects from a graduate. When they are moving out of this course, they should be in a position to design this intelligent machine and fabricate it. This is what the major, we call it as program specific objective, PSO. This was our first PSO. Then second PSO we have defined as, they should be in a position to identify the real life problems with the help of the multidisciplinary culture what they have developed in the department. They should be in a position to provide a solution for it. These are the 2 PSOs we have identified. For this, our curriculum has been modified and we have introduced a lot of new things into it. Quickly, let me show the curriculum alone for you so that you can comprehend what are the changes we have brought in. So if you look into the semester-wise curriculum, so first is communication skills, employability skills. If you consider, we do have certain courses like communication skill. Then we have communication 2. Then we have, in the later part, in the 4th semester onwards, professional skills training, or they should undergo industrial training. So generally we start our internship aspects in the 4th semester onwards. So in the 5th semester, again, professional skill training 2. That is, in the case of professional skill trainings, we provide them, we divide this into 3 modules. One is based upon the soft skills. Second one is based upon the coding, that is required to meet out the things, maybe coding in the form of languages or any front-end development or back-end development, or integrating these 2. Let them develop a small app or let them develop a small software for a particular problem. And third category is introducing students to the logical reasoning, analytical reasoning, and all those stuffs. So if you consider this employability skills, we take communication as the first and foremost, second one programming, third one related to reasoning. These 3 aspects are taken into account and we define this new set of courses. Similarly, for programming, if you consider, we start with first semester, we are having problem solving and programming in C. Then followed by, we have data structures in C, because without knowing in depth about data structures, we cannot find application for it. Okay, so if they are able to comprehend C programming and data structures, if they are able to use it and they can develop certain things, any language they can do it. So that is the idea. So we start with programming C, then followed by data structures in depth in C. Second semester. Third semester, majority of the courses, they have Java programming, and in the fourth semester, Python programming. Because when you get into robotics, majority of our applications goes with data structures and Python programming. So this is all required when you want to define a intelligent machines. So one is employability course. In that, coding is one part, programming skills is one part, communication skill is another part. Third part is your reasoning and analytical ability. All those stuffs we are brought into the curriculum itself. So apart from this, we do have professional core, professional elective courses, and yoga and values for holistic development. This is a non-credit course, and students induction program, as I pointed out, it is made as a mandatory course without credits. For yoga, at least we provide a credit so that holistic development is taken care from the first semester onwards. And remaining thing is as usual, it is either all these stuffs belongs to either engineering courses or humanities courses or professional core subjects. These three categories are focused on the first 4 semesters. So mathematics is there because it is a mandatory requirement. And if you look into this workshops, we have modified this laboratories. First year, as I pointed out, let me come back to the world skills. We focus on these being creative part. Okay, so we focus on welding, web technology we have taken in the creativity part. Web technology we have taken as one of the core thing. Then mechanical CAD we have taken to a second category. Third, we have gone with that's all from this category, being creative. And in the complex design problem category, we have taken prototype modeling. So unless otherwise he develops a small prototype, he will never feel the importance of engineering. So this is also brought in the first year itself. So one is web, second one CAD modeling, third one prototype modeling. This is for all the departments. Then we have gone with under craftsmanship. We tried for masonry work, but since we are unable to provide for the entire campus, time being we have dropped it. Okay, in this category we have taken only welding. Welding we have taken under craftsmanship category. Fixing things, we have gone for instead of car painting and aircraft maintenance and auto repair, generally we have taken electronics here, so that a candidate develops a small circuit, develop a PCB board for it, okay, and with that board he develops a small applications. For example, they develop small robots or some drones. This is what it is done with electronics. This is another idea we have identified.
Sir, here I have a question, if you don't mind.
Yes, sir.
These skills are looking like welding technology or carpentry or masonry, all these things, like looking like an ITI guys or something like that, correct?
Yes, sir.
How our guys like BTech guys and all, they will be see now, you know, that younger generation, they all want a white collar job, correct? Earning a lot of money and all those things. So do you think that a BTech guy, by paying a lot of money and all those things, they will be interested to do the welding and all those things?
Yes, sir. One thing is, we also discussed this point, and we narrowed down to the point that unless otherwise we give a hands-on training to them, they will never get interested in engineering. With that idea, your non-Mudalvan scheme, Tamil Nadu government,
that scheme is there. Tamil Nadu government started.
they came out with this idea when they visited Banari Amman Institute.
Which university, sir?
Banari Amman Institute of Technology in
Okay.
Satyamanglam. They developed, to tell the success story, 4 students from Banari went to the international competition in the current year. and they have participated in the international competition representing India. Indian skill development authorities, they have identified, groomed these students over at states, but they will have a state level competition, then national level competition. It is not going to be an easy task, but still they have done it and they have made it. So based upon the success story, now these engineering graduates, once they are able to develop a prototype of what they feel, they get interested in the next. The biggest challenge for our community is now is to make the students to focus on engineering and to have a liking towards engineering. That is the biggest challenge now. So we, instead of having a conventional workshop in the first year, first 4 skills we have identified in the first semester. Similarly, next 4 skills we have identified. In that we have identified day-to-day things. For example, we have introduced one course on home appliances. That is dismantling of home appliances and identifying the maintenance work or repair work in the home appliances, they should do it. Similarly, dismantling of automobile, bike, say bicycle, one component is given, another component is your automobile bikes are given. That is one skill set in the second semester. And we have also identified electrical connections. For example, a room is given like this, drawing related to a room is given, you specify the specification. For example, I need 1 fan, I need 2 tube lights and 1 plug points to have it. And for this, they have to design the entire electrical line layout diagram. Then they have to fix it. They have to complete the process, starting from your MCPs to the fans and everything control. They have to design and they have to first sketch it using softwares. Then they have to implement it in the real environment. So all these skills, as you have pointed out, we are trying it as an exercise. It may work or it may not work.
See, you see what you are thinking is correct only. See, nowadays, if you see, an electrical engineer may not know how to set up the bulb and all those, that wiring and all those things, but he might have studied BTech electrical engineering or
Yes,
something
sir.
like that. So that way, it is, yes, you are right. Whatever you have said is correct. Even mechanical engineer also, you may not know what is welding, how to weld it also. But if he knows, it is better. But the problem, as you said, right now, the younger generation.
Yes, sir. That is also a challenge is there.
Yes, challenge is there. They may think, sir, this is the work of ITI guys. Why should I do it in my life?
Yes, sir.
I'll be a manager. I'll be a supervising engineer.
Yes,
Like
sir.
that, you may think, na?
That is the idea, because one is we have to convince them that this is going to make them feel engineering. Unless otherwise they feel, these generations won't accept it. So we have to start somewhere. Instead of giving conventional woodworks, carpentry works alone in the first year, or small foundry works in the either in the first year workshop for everybody, we are moving towards this skill building. We have identified, because of the success story of Banariaman Institute, we have started from there. They have started 3 years ahead of this activity, and they find that they are able to compete in the various hackathons across the world, across not only in Pan India, they are now moving towards across the world. So this creates, maybe for the initial first year, once when you are introducing, they may feel it as a difficult. But when they understand the success story, they feeling engineering in their hands, automatically interest is created. One biggest challenge is now to create interest among students is the biggest challenge. So with that idea, we have introduced for this year alone. Maybe depending upon the success, we may continue or we may revert back to the old system. As a autonomous body, college, we are able to try it out.
Correct. So one more thing, in your this curriculum, when I'm seeing now, it is like semester based fixed. So, but nowadays, work is like what you call fully flexible thing. You give it in buckets, they can choose whatever they want. Correct, na?
Yes,
so when you say the multidisciplinary thing, the choice, where is the choice here?
Yes, choice comes only from the understanding the fundamental subjects. In the first 2 years, there is no choice for them.
Okay.
But in university systems, you are able to provide. But in
Okay.
our system, we are confined to not providing chance for them in the first 2 years. Fundamental, we want to cover it.
Okay.
Then later on part, we want to give the flexibility.
Okay, sir.
That is also done. So one thing I want to say is identify the skill set required for employability, skill set required for your domain knowledge, basic things, and lastly for entrepreneurial vertical also. So in the case of entrepreneurial vertical, we introduced design thinking in the 3rd semester. In the 5th semester, we are having a paper called Innovation and Business Model Development. It is an elective papers. Design thinking, it is a core paper, but in the electives, we provide business model development, innovation and business model, then followed by entrepreneurship. Then comes your startup culture, whatever be the case, given the venture capitalists and how to raise money, financial aspects we are covering. So a person, those who are looking for a particular stream, they can look into that aspect, they can start it. So this is how we have done this curriculum. And why? Since it is a multidisciplinary course, already we are into it. So we do have papers from across all departments. We give provisions for them. And if you look into our employability course, in the recent thing, we have increased it to 19 credits. And open electives still, we are lagging with the AICTE requirements, but we have to improve on this one. So, but employability courses, communication and coding and reasoning ability, we are able to do it. We have increased it. And these are the split ups. And we are divided into 3 streams because it is a multidisciplinary domain: mechanical, electrical, automation, and information systems. So if you look into this culture, already multidisciplinary approach is there. But when you consider a conventional course like civil engineering, or when you are dealing with mechanical engineering, you have to slowly build this culture where they can take it up from the open elective first. Then if it is successful for them, let them bring it as a core elective or professional elective. Then slowly let them convert it into a core paper. It will take time because the regulations, if they go through, they can identify the essence required for it. For example, if you deal with mechanical means, the current trend is all about digital manufacturing. So if it is, you want to have digital manufacturing as a major thing, then focuses towards you should have some exposure to electronics first, then programming part, then your mechanical structure. Lastly, it comes into picture. You need to integrate all these stuffs when you are designing a course for them. Since our course is already a multidisciplinary course, we are able to make a compromise on it. So 28 credits we are focused on mechanical thing because we need to, it's all about the science of intelligent machines. 28 credits. Here electrical 23 credits. For automation side we have done 15 credits, and for information system it is 24 credits. So it is equivalent to electrical engineering stuff, electrical and electronics engineering. This information system weightage is also considered. So integration of all these things are required when you define a courses. So few courses we have dropped. Let me, time being, since we are running out of time, I skipped all these things. Few courses what we have introduced, let me come back. Look at this one, digital twin and industry 5.0. We are looking at the from 4.0 to the next version 5.0, where the machines become human friendly ones. You need to devise the machines which are very human friendly. That is, will be the agile in nature. That will be the task for industry 5.0. All these new electives we have brought in, and open electives. For somebody is interested from other departments, they can take these courses. First, design of mechatronics system, business model development, factory automation, data acquisition and virtual, and these stuffs. 3D printing, drone system, robotics, VR and AR, all those stuffs are delivered as an open elective for other departments. These are core papers for us. In addition, it is offered as an open elective for other department students. So we don't stop here. Wherever possible, we try to have industry expertise, we bring it into our curriculum. We provide a provision for having 1 credit, 2 credit, 3 credit courses in collaboration with industry expertise. So for normally, for a robot operating system, we do have collaboration with Fanuc recently and with Caterpillar also, and Siemens for PLC programming, EduTech for PCB board, MathWorks, LabVIEW, then Rockwell Automation. These are the industries we have identified. We collaborate with them. For a 1 credit course, 30 hours are considered. It is treated like a practical paper. 30 hours is taken. Maybe for first 10 hours, our expertise is used. For remaining 20 hours, industry expertise are brought in. So this is how we offer. And again, we promote students to take up international certification courses. For example, LabVIEW and SolidWorks, we currently focus on, and Fanuc also, we have gone for robot programming and CNC simulation process. These are the international certification courses which are facilitated in the department. So like this, you can add flavor to your curriculum so that where you provide a provision for them to earn extra credits, maybe the 20 credits for honor degree or additional courses, they can do it so that they can make 180 credits if they are going for higher studies abroad. This provision is also given in our curriculum structure. So to give a glimpse of the department facilities and what are the availability, maybe for current trends, mobile robots and drones, industrial robots, smart mechatronic systems, digital manufacturing, we do have a great facility for us to facilitate these new courses. And to summarize, these are the best practices we follow. We do have an industry attachment program with 2 or 3 industries. One example is like Roots Industries. We do have a course for manufacturing course. People from Roots Industries come and teach us. A portion of the 3 days or 4-day workshop is conducted. They take conceptual teaching here. Then they take the students to the industry for 1 day, full day, or 2 days. They keep with them. They teach what they have learned in the conceptual class. They expose those candidates to them, and wherever possible, we encourage the students to have field visits. An average 4 to 5 field visits are given to each semester. In each semester, students undergo 4 to 5 field visits. Industrial visits are there, but subject-oriented field visits are also taken into account. And we encourage capstone projects, that is identifying the ideas from the 2nd semester on 3rd semester onwards up to 6th semester. We nurture them. If it is a potential idea, that is given back to our TBA, where we do have a provision for before that seed money is given to them while they are developing. If the idea is good, then TBA supports them. With the help of TBA, they are able to develop products. And if it is patternable one, we advise them to go for patent. Or if it is a commercial aspects is there, we try to connect the investors. We bring in a lot of support either through mentoring or through financial aspects we are providing. So these are the things we are having, and we do have LabVIEW Academy. Additionally, they are learning. Majority of our projects are converted into papers. Students are exposed to all these contents, and with the help of innovation or your project laboratory in the department, they are able to compete with the various hackathons across India, and majorly from IITs and NAACs. If any hackathons are happening, again, Smart India Hackathon or whatever be L&T recently announced hackathon. KPIT Sparkle in Pune, they came up with an innovation. Out of 100 ideas across Pan India, 14 ideas are from Kongu. So this type of culture we are creating. These are the best practices, and participative learning, practical oriented assignments, exposure in the science, other sports, cultural things we are giving credit. Nowadays we have brought in credit for NCC. We have brought in credit if there are some flavoring, good things in sports and cultural. These things are already brought in. And to conclude, you know that engineering is a practice-oriented course. Hence, we need to produce graduates who are able to practice it. So from engineering graduates to, we need to produce engineers. A lot of criticism is among the professionals across India. They criticize our colleges, that colleges produced only 18% of employable candidates. So they claim that only 18% we are producing engineers. But slowly we have to move from this. We should accept it. We should move from this point to where we produce engineers, not engineering graduates, engineers. That is my idea. So it should start from your curriculum. Once curriculum is defined, then automatically you have to change your teaching learning methods. Then you have to change your assessment methods. Maybe the future speakers will dwell on changing our engineering assessment methods and teaching methods. They will be dwelling on this aspects. And the outcome of any engineering profession is utilization of scientific facts and the concepts to solve problems for the well-being of this society and human being. Lot of problems are there. In India, population is higher, problems are also higher. So you can walk through, you can observe, you can identify a problem. For example, if you consider last week, I was making a walk in the ground. The ground person who maintains the sports facility in the ground used to throw the pieces of to mark the line. He used to bend at least for a full round. He should bend at least 400 to 500 times in order to complete the entire round with white marking. So at the same time, he is exposed to the content available in the chalk what he is throwing. So it is harmful to him. At the same time, he is bending. It is not an ergonomically, it is advisable method. So if you are able to come out with a solution for it, then it is a better one. So devise a small element which will drop. Normally these chalk pieces won't fall directly. You need to identify a device which will have a continuous flow of it. Due to gravity, it should come. It should not bend, it should move. Simply rolling this vehicle, he should complete the entire process. If that is happening, then we are able to apply our scientific facts on the real-time problem solving. This will happen. And let us focus on higher order learning level from 3 to 6. It is advisable. Our question papers and our assessments are everything should fall under the higher order learning. And finally, if this is the curriculum we are going to develop, we can get innovative problem solvers, we can expect campus startups, and we can produce ethical human beings for the near futures. With this, I thank everyone for listening patiently for me for the past 2 hours. And any queries or anything I will be in a position to explain. Sir, any queries?
From my side, no queries, sir. Good, sir. Your teaching is excellent. Very nicely explained. Good.
Thank you, sir. Thank you, sir.
Thank you. Thank you.
I think you are the active participant today.
Okay, sir.
Rashi, ma'am.
Thank you, sir. Sir,
Thank you, ma'am.
participant side, sir. Sir, can you able to hear me?
Yeah, we are able to hear you.
Hello?
Yeah, we are
sir,
able to hear
I think
Manishri.
there is
Then
no.
go ahead.
Okay, sir. So I think there is some network issue for Priya, ma'am. So she can't able to join the session, sir.
Yes, ma'am. Yes, ma'am. I understand.
Okay, sir. So I'll conclude it. So thank you, sir. Thank you so much for your valuable speech on restructuring of curriculum towards a holistic development for employability, research, higher education, innovations, and startup and multidisciplinary domains expertise, and this will be helpful for the faculty to design and research the curriculum, sir. So thank you so much, sir. Valuable speech. Thank you once again, sir.
Thank you, ma'am. I thank all the participants for bearing with me for the past 2 hours. Thank you very much.
Thank you, sir. Thank you, sir.
Thank you all.
Thank you, sir. Thank you, sir.
The participants, I have posted the feedback link in the chat box. Kindly fill the form.
Ma'am, while trying to fill the form, it is getting redirected. Kindly check and resend, madam.
So I will send once again, sir.
Okay, thank you.
Okay.
Ma'am, shall I take a leave?
Okay, sir. Those who have filled the form, kindly leave the session, sir.
Thank you, ma'am. Bye.